Assalamualaikum warahmatullahi wabarakatuh. My name is ZAIRY bin JAMALUDIN. We from Group E, and this is the video for assignment vehicle dynamic, and our title is semi-active suspension system. So, semi-active suspension system is a type of automotive suspension system that controls the damping force of the shock absorber in response to input from continuously varying road surfaces. It is intended to approximately implement the active suspension with a damping force adjustable shock absorber. The semi-active suspension system is based on passive and active system. The presented one contains instead a passive shock absorber and a variable shock absorber as an active damping force that is automatically controlled by an integrated regulator. The damping force is modulated in accordance with the operational conditions which are continuously controlled by sensor connected to the CPU. So this is a literature summary for Journal 1. So methodology, number 1 is vehicle mathematical model. In this analysis, researcher use a multiple mathematical equation, and this equation of motion are for multiple response of the vehicle, which is for bounce, pitch, and roll response of the vehicle body. Number 2, simulation using 4-poster hydraulic shaker test rig. The 4-poster hydraulic shaker test rig, which is available at the Institute of Automotive Engineering of the Technical University of Braunschweig, is used for the verification analysis of the mathematical vehicle model. A schematic and drawing of the 4-poster test rig setup with the test vehicle measurement instrument is shown in the figure. The hydraulic cylinder of the test rig have dynamic force limit of 21 kN together with plus minus 125 mm displacement range. Furthermore, 30 Hz low pass filter is used for filtering the road profile and the measurement signal. Number 3 is control strategy. The control process starts by providing the body velocity and acceleration to the role optimized fuzzy logic controller. The controller uses this information to generate the demanded damper force. The additional semi-active damper control law given is used to calculate the value of damping force, which is inside the controllable damper limit according to the demanded control signal and the damper velocity. So the result are from verification result, transfer function magnitude of body and rod displacement at each corner for soft and hard dampering setting, comparison between simulation and measured transfer function for verification of model accuracy, and road roughness, vehicle speed and vehicle load influence the performance of the suspension.
Hello, Assalamualaikum. My name is Muhammad Safiq and then Muhammad ISAK. I will present this channel. Its name is Model Semi-Active Control Semi of Suspension with MR Iterator for the variation attenuation. So methodology, modeling of quarter automotive suspension and MRD dynamic. So first is vertical model of quarter car. So definition of this of dynamic relationship of spring mass and the unspring mass. So the next one is MRD dynamic. This work consider a polynomial model of for the MRD. The polynomial model parameter can be experimentally estimate for the force displacement measure only, and the model is expression for the damper force as a function of the piston velocity and the input current of damper. So next is this turbulence rejection control design. So the control same here alone for the indirect regulation of the system state by the regulation so of the so-called flat output. thereby fulfilling both objective of achieve comfort and the road hole. So the model and multi-model control design. So first is positive position feedback control design, and the second one is multi-positive position feedback control design. So the first one is PPF terminology come from the fact that the positive coordinate of the structure equation is positively fed to a ritual second order fluid, and the position coordinate of the compression equation positive feedback to the structure. The multi position MPPF is model control with strategy attitude mechanical variation on different model, which is a extender of FPP approach. Similar at multi-virtual pace absorber located in the parallel form to the primary system. So the passive base control PBC design. Passive system are the class dynamic system which control store more energy than the supply for the external source. This police sufficing for the absorbing regulation task in the mechanical system using PBC approach by modifying the potential energy and the dissipation function. So next is the result. So comparison TFR of the spring mass displacement tire defect for the different current input. So the analysis of automotive suspension report implemented in this session evaluate the proposed SAC science is the comfort and the road holding perform of the suspension can be evaluated with the transmissibility frequency response of the spring mass displacement and the tire deflection displacement. So next is the comparison TFR spring mass displacement and tire deflection of different damper control. The effection of three considered proposed in this work compared through numerical simulation. The PPF expressed in the equation designed for two different objectives. So first, vibration mode improve low frequency, and the second is the high frequency. So next is comparison TFR spring mass displacement tire displacement and tire deflection for the different damper control and variable this spring mass. So S1 observe soft suspension represented by open load operating is the worst evaluate in both criteria. On the other hand, a rigid suspension operate improve both performance indicted. So the last one is damping force for the proposed semi-active control, and the MRD power consumption of proportion at SAC. Finally is present maximum damper force and the power consumer of the MRD of each proposal SAC similar corresponding to the result. This value are calculating for each frequency of proposal distributions. The obtained damper force are with the rigor for maximum force proved by the MRD considered in this work.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is ZAIRY NASRIL. Okay, I will talk about my journal, which is the title is Hybrid Control Strategy for a Semi-Active Suspension System Using Fuzzy Logic and Bio inspired by Chaotic File Algorithm. Okay, name of my journal is the Department of Electrical and Computer Engineering, Carnegie Mellon University. Okay, year published is March 2017. Okay, okay, for the methodology, the first one is the semi-active suspension system and the quarter car model. Okay, the semi-active suspension system reduce power consumption and increase vehicular stability during transportation compared to the active suspension system. The system utilizes a damper whose characteristic can be changed externally using controllers in contrast to the fixed conventional active and passive system. The design of the semi-active system can be represented with a quarter car model where the masses can be classified into sprung mass and unsprung mass MU. The sprung mass is damped by the suspension system and the unsprung mass consists of the mass of the component of the vehicle system such as the brakes and the steering wheel. Okay, the second methodology is a fuzzy controller for MR damper. A fuzzy controller works on a set of rules that are based on the mathematical analysis and system modeling. The rule base consists of a if-then rule statement indicate condition for control. The parameters are the input of the fuzzification interface where conversion to fuzzy information occurs. After comparison with the fuzzy rule set, the, the fuzzification convert the conclusion to actual parameters. Okay, for the third methodology is the fruit fly algorithm with PID tuning. The fruit fly algorithm is an optimization procedure which utilizes the food finding behavior of fruit flies. The FOA generates and initializes a location for the swarm, and then each member is assigned a direction. The best position is then estimated based on a judgment function when they reach new position after an estimation of the distance to the origin and the corresponding smell, which is the reciprocal of the distance. The optimal solution is reached after the series of iteration. Okay, the third methodology is the fourth methodology is chaotic fruit fly algorithm. The chaotic fruit fly algorithm, an improvement on the fruit fly algorithm, incorporates chaos into the generation of random data for the purpose of updating location during the optimization process in order to solve global optimization problem. Okay, for the fifth methodology is PID tuning using CFOA. This paper introduces the utility of the chaotic fruit fly algorithm in the tuning of a PID for the control of the suspension distortion. The judgment function defined by and calculated by the closed-loop dynamics performance of the suspension system was minimized after random initiation of the location of PID parameters. Minimization of the judgment function returns the optimized values of the PID parameters, similar to the CFOA, the after initialization of the parameters and logistic research. The dynamic performance of the PID system has been calculated using the input error and output variables. Okay, for the result, the guiding equation of the semi-active suspension system tuned by CFOA based fuzzy PID was solved using Simulink and based on the optimal values of the PID gain parameters. Its performance was judged. The sprung mass acceleration, tire loading, and the suspension distortion for the proposed system were compared with those of the active system. ZN-based PID fuzzy hybrid semi-active system, GA-PID fuzzy hybrid semi-active system, and similar PID fuzzy hybrid system, tuned by swarm intelligent algorithm like PSO and BFO respectively. Okay, the fruit fly route to the most optimal solution when the initial condition of the PID were defined by conventional ZN tuning.
Okay, for the next slide, my name is AMERUL AZHARI. So for the next slides is about my journal. So the topic of my journal is adjustable valve semi active suspension system for passenger car. So for the methodology, they have three methodology. The first methodology is analysis of electrical controllable damper. When in compression, the fluid always through through two flow paths through the internal piston and external bypass valve. The damping through the internal piston in detected by the area of the office are the stiffness of the shim stack, where the flow through the bypass valve depends up the adjustable displacement pin that is controlled by the application of the voltage. So for the second methodology, flow rate estimation. So the damper force can be expressed as a pressure drop and the difference of the cross section of the piston tube and the piston rod as expressed in the equation. The F damper equal to alpha P in bracket a tube apostrophes A rod. So for the last methodology is the working principle. So a slider was used to vary area according to the input pulse to the stepper motor. Changing the position of the orifice are categorized into four states. These states are referred to the adjustment from soft to the hard, respectively. In a table 1 show the damping state category. So for the result, there has 1, 2, 3, 4. There has a 4 result. So the first result is the damping state category. A prototype was built at a road test was performed to obtain the result in terms of the acceleration, transition, acceleration in both transitional and rotation with S time. The suspension consists extensionally of the two electrical controllable damper and the control unit. Each shock absorb contain a step motor. So that's the result for the first result of the damping state category. So for the second result is acceleration analysis. In acceleration analysis, they have three results. So for the first, acceleration time for the different adjustment at graph A, speed bump, and the B graph is straight road. So for the second acceleration analysis, lateral acceleration time for the different adjustment at A, speed bump, and at B, straight road. So the last acceleration analysis is a vertical acceleration time for different adjustment at the A, speed bump, and at B, straight road. So for the third result is a car body analysis. They have two results in car body analysis. So for the first is the rolling angle are different adjustment at A, speed bump, and at B, straight road. So and the last in the car body analysis is A, rolling, and B, pitching angle are the function of a time. So the last but not least, the result, right equality evolution. So the compression between the measured road mean square has the standard value of the comfort reaction and exposed to human body vibration as described in ISO 261. It can be concluded that when the absorber adjustment of the softener state that in straight road with the speed above 18 km per hour and the reaction is little uncomfortable because the car tends to be bouncing, but the state change to the harder level and reaction move to a comfortable zone. So that's all for this slide and that's all for me. Thank you very much.
Hi, my name is RUZATUL RASLAM. My matric number is B0919100082 from BMMA section 2/1. So, for my part, journal 5, right comfort optimization via speed planning and preview semi-active suspension control for autonomous vehicle on uneven roads. So, for the methodology, road profile information. Due to autonomous cars' excellent environmental awareness capabilities, The types of road profile information are studied in this paper. Preview road information and global road information of a given driving path. Next, dynamics of semi-active suspension. It is to design the preview suspension controller, a quarter of vehicle model. Then, multi-objective problem. It is requirements. The driving time is minimized. The comfort performance in each RI is optimal. The sum of B during the entire trip is minimized. And the last is the preview suspension can adapt to the speed variation. Next, we have vertical performance simulator. A simulator is proposed here to calculate the vertical performance of a vehicle traveling at V speed along a rough road length and height function. Then manipulation of global information. It developed a speed planning problem in the spatial realm using global road information. The final speed trajectory is obtained by simultaneously optimizing the vibration, driving time, and vehicle acceleration. Using the dynamic programming principle. In this portion, the global information will be changed to create a dynamic programming challenge to support with the description. The manipulation figures show 3 rough road and 4 general road. So the last methodology that we find in the journal 5 is the dynamic programming. According to the dynamic programming principle, the globally optimal speed trajectory may be found by solving the solving the following minimization problem from P from PM to PO. Next, we move to the result of journal 5. We found two results which are comfort performance of constant speed and also multi-objective performance and plane speed. The performance, so for the comfort performance at constant speed, the performance of the hybrid HVMPC method at various constant speed and on a variety of typical roads will be simulated in this section. To further illustrate the characteristic of the proposed controller, we simultaneously evaluate the suspension performance with a sample time of 1 millisecond and a simulation step of 1 millisecond for the following control methods in order to better reflect their characteristics. In the following section, this control method will be evaluated under two different types of pavements, which are designed as independent long wave roads and serial short wave roads, respectively. The first one, independent long wave roads. In this case, an independent bump is used to simulate long wave pavement. Given the length and height of the bumps, the pavement can be described by a sinusoidal function. Then, serial shortwave road in real-world driving conditions, the bump may not appear independently. It has been possible to introduce pavement geometry with serial bumps, for example. Then we move to the multi-objective performance at plane speed. Speed planning and hybrid HVMPC performance are evaluated using a road profile at varying speeds. There are enough random profile in between the bump roads to meet ISO 8608 requirements. Weighting parameters have a direct effect on the trajectory of the vehicle's speed and its final performance. The hybrid HVMPC method with speed adaptability is used in accordance with the proposed structure at the various planned speed trajectories. The simulation results show that the hybrid HVMPC method can take advantage of the long-term vision and effectively improve comfort, performance, and field speeds. In addition, it has been found that the speed at which a vehicle travels on uneven roads can have a significant impact on its overall comfort. So, for the conclusion, for our assignment of semi-active suspension, semi-active suspension system improve not only the ride comfort and control of the vehicle, but they also improve the vehicle's road holding. These systems have the ability to adjust the amount of damping in response to measurements of the vehicle's ride and handling characteristics. In recent years, people have become more concerned about how their cars affect the environment, how much energy they consume, how safe they are, and whether or not they are comfortable while driving. In contrast, modern automobile technology has progressed to the point where it is extremely difficult to improve the mechanical structure of a vehicle. Automotive electronics technology has emerged as the latest fashion in the modern automobile industry. That's from me. That all from me. Thank you.